Welcome back, physics fans. Here we are on scientific notation, lesson number 2, it says, on physics 11. And it's a universal method to write all numbers. Universal meaning we want the whole world to understand what we're doing, and then when we read their numbers, we want to know what their numbers are. So it's just the way that we do it in science. Okay, the original number, I'm just going to point it out painfully here with the first example. The original number is 4,321, and we would like to be able to write it in scientific notation this way. The first way to do it is take the first number, as long as it's not a zero, and we write it down. The next step is put a decimal point, so it looks like this. Then we write down the rest of the numbers that are not zeros, 3, 2, 1 in this case. Now we write times 10. We write that. We're actually not thinking math here. We're just doing the symbology of here. And now the toughest part, as you can see, because there's so many steps here, is writing that exponent, getting that 3 that's there. Which way did you move the decimal determines the positive or negative. What do you mean decimal? Well, it was 4, 3, 2, 1, and we ended up with putting the decimal 1. Whoop, let's just get that going here. 1, 2, 3. We moved it 3 times. Okay? How far did you move it determines the number itself. So I moved it 3 times, and this is where it ended. So we started here, and we ended here. So it's a 3. So we got 4.321 times 10 to the 3. But now, most important at this point, is it a positive 3 or a negative 3? It was moved to the left, making it a smaller number. So this 4.321 is much smaller. We have to make it bigger to get it back to the original. So we have to multiply it by 1,000. So that's why 10 to the 3, positive 3 is 1,000. And that's why it is. So if you can't remember that way, left, if you move the decimal to the left, it'll be positive, and moving it to the right will be negative. You could use that rule, okay? So if you move the decimal that way, it's positive, and you move the decimal that way, it's negative. Okay, so that's how you got the positive. Let's try this 3,600,000. So you write down the first two numbers, 3 dot, and then the 6. And then we write down times 10 to the, and then what do we do? We want to write 3.6, and we started here, so we went 1, 2, 3, 4, 5, 6. We went that way, so it's a 6. And then because we went to the left, it's a positive. So the answer is 3.6 times 10 to the 6th. Okay, so now how do we, example number 3, it's 5.6. We write down 5.6, but then how do we do it? We moved it 1, 2, 3, 4, 5 that way. So that's going to be times 10 to the negative 5. Here's another one, number 4, 201.02. We're going to be moving the decimal places 2 to the left. So this is going to be 2.0102 times 2, 10 to the 2, because it's 2 to the left. And then we have 0.05051. This is going to be 5.051 times 10 to the, and we moved it 2 to the right, so that's going to be 2 to the negative 2. It's, okay, Google. Google, it's actually spelt a different way. The company changed the way to spell it, but the word Google came from a number. Okay? And so we load up Google and we tell it to say, what is a Google? I think I spelt it wrong. Here we go. Googol is the number. Okay? And a Google is a large number. It's 10 to the 100. Okay? And in decimal notation, it is written by 1 followed by 100 zeros. There it is. It's written for you. That's a lot of zeros. We definitely don't want to write that down. So how do we write that down in scientific notation? It is 1 times 10 to the 100. Not so good, not so great, that's good. There's even bigger numbers than that have names. There's one called a Googleplex. And that's 10 to the power of 10 to the power of 10, I think. And so that's 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, one too many, I think. And how big is that googolplex? We can't think about how big that is. Our brain can't conceive how big it is. If you took protons right beside each other and packed them in for the whole size of the universe, we're nowhere close to that. So that's crazy. So we don't even talk about it. Mathematicians come up with weird numbers. This one looks like it's in scientific notation, but it's not proper. Let's fix it. What it is, we move it one to the left, and this is going to be 4.32 times 10 to the, now we had one more to the exponent, it's a 3. So what is this last number? Number 8? Work on it ahead of me instead of just copying it down. Yes, 4.32 times 10 to the, and then we went 2 to the right, so we had to lower this number, it'd be the 17. And what is this number? 30 exclamation mark. What does that mean? Does it mean 30? No, that's a mathematical function. Like you see 30 squared, you see square root of 30, right? These are math functions, square and square root. What's what's that exclamation mark? Anyone know? No one knows? They call it factorial. 30 factorial. What is 30 factorial? 30 factorial is 30 times 29 times 28 times 4 times 3 times 2 times 1. That's 30 factorial. It's the products of the numbers all the way up to that number. So 2 factorial is 2. 3 factorial is 6. 4 factorial, whoops, 4 factorial is 24. 5 factorial is 120. 6 factorial is 720, I think. It gets big pretty fast. What's 30 factorial? Well, calculators have it. Calculators have it. In this weird calculator, this math one, this TI-84, you have to go to the math functions. So you go 30, and you go into the math functions, and it's going to be underneath probability. It's underneath probability, and then you see there's an exclamation mark there. So this is going to be 30 factorial. It equals, and it tells us what it is. In case you didn't want to spend 2 minutes of going 1 times 2 times 3 times 4 times 5. Okay, it took you 15 seconds. Good. Did you get this number? Uh-huh. So it stops you also from making errors. So that's the value of 30 factorial. Thanks for joining us.